Two cataclysms, separated by hundreds of millions of years, have left a deep mark on Earth's history. One wiped dinosaurs off the face of the planet, while the other may have paved the way for their rise. Scientists investigating mass extinctions have uncovered astonishing connections and evidence linking both events to cosmic impacts that altered the course of evolution. It all began with the attempt to understand how the Chicxulub meteorite, which struck 65 million years ago, managed to wipe out 70% of all life, including the dinosaurs. The devastating effects of this catastrophe captured the attention of paleontologists and geologists. The key evidence for the meteorite's impact was iridium, a rare element found in the soil layers from that time. Its unusually high concentration matched the boundary of the Cretaceous-Paleogene extinction. Gradually, scientists shifted their focus to events that occurred 250 million years ago, during the end of the Permian period. This marked Earth's most massive extinction event, wiping out approximately 90% of marine life and 70% of land species. Researchers questioned whether such a grand-scale catastrophe could also have been triggered by a meteorite impact. Global expeditions led to discoveries that supported this hypothesis. In deep mines, scientists found elements indicative of extraterrestrial origins, including iridium. These findings, along with distinctive traces of ancient impacts, pointed to a powerful cosmic collision that shook the planet. Computer simulations confirmed that the energy released during the impact had far-reaching consequences. A seismic wave traveled through the planet, triggering massive volcanic eruptions on the opposite side of the globe. These eruptions, located in what is now Siberia, created immense lava fields spanning more than 770,000 square miles. Scientists believe that the volcanoes released enormous amounts of gas and ash into the atmosphere, leading to severe warming and ocean acidification. However, the deadliest threat came from hydrogen sulfide, a toxic gas formed by changes in the ocean's chemistry. Over thousands of years, its concentration increased, eradicating nearly all marine life. To validate this hypothesis, researchers turned to modern-day analogs of ancient conditions. One such site was a lake in upstate New York, where oxygen is entirely absent and hydrogen sulfide is released from the lakebed. Water samples revealed that bacteria in these conditions consume the remaining oxygen and release lethal gas, wiping out all surrounding life. This finding became a crucial piece of evidence linking chemical changes in oceans to mass extinctions. Despite the colossal devastation, the Permian meteorite impact did not leave only barren wastelands. The vacated ecological niches became a breeding ground for new forms of life. It was during this time that the evolution of diapsids, small reptiles, began, eventually leading to the rise of dinosaurs that would dominate the Earth millions of years later. The world we know today has endured catastrophic events that reshaped its history and landscape. Millions of years ago, when Earth's surface consisted of a single supercontinent, Pangaea, a massive meteorite struck the planet, leaving behind permanent changes. Scientists spent years unraveling the reasons behind such destructive events and uncovered numerous clues pointing to this celestial body. The first discovery hinted at a massive crater buried in Antarctica. Studies revealed that the force of this meteorite's impact far exceeded the destructive power of the Chicxulub meteorite that wiped out the dinosaurs millions of years later. Using supercomputers, experts reconstructed the chain of events following the impact. Immediately after the strike, Earth was thrown into chaos. For the next 20 million years, the planet's surface remained nearly lifeless. The atmosphere was filled with toxic gases like hydrogen sulfide, making survival impossible for most organisms. Yet among the few survivors was a group of small reptiles known as diapsids. These creatures became the ancestors of dinosaurs, which would go on to dominate the Earth for millions of years. Modern technology has allowed scientists to simulate the potential consequences of a similar event happening today. If a meteorite 25 miles in diameter were to strike the center of North America, the immediate catastrophe would claim millions of lives. The city at ground zero would vaporize instantly. Within a radius of 186 miles, all life would be obliterated, and a fiery blast wave would destroy everything across several neighboring states. Minutes later, fragments of the meteorite and the debris it generated would begin raining down, devastating areas over 435 miles away. In the first hour, tens of millions of people would perish, but this would only mark the beginning of a global apocalypse. The firestorm, fueled by the massive release of energy, would spread across a radius of up to 1,243 miles, while an 11-magnitude earthquake would obliterate everything within 311 miles of the epicenter. After the firestorm subsides, an even more destructive phase would begin: the shock wave. Traveling at an incredible speed of 466 miles per hour, it would ravage an area within a 1,864-mile radius. Within hours, the North American continent would be reduced to a barren wasteland devoid of life. This scenario underscores the vulnerability of our planet to cosmic threats. Despite humanity's technological advancements, we could find ourselves in a situation similar to the one that led to the extinction of the dinosaurs. Fortunately, the likelihood of such a massive meteorite impact is extremely low. Events of this scale occur only once in hundreds of millions of years.